Hi everybody, welcome to You Can Do Math. Today we are going to write the equation in slope-intercept form, y equals mx plus b, when given the graph. All right guys, let's get started. We have 6 examples for today, and each one is extremely important for you to truly understand how to write an equation in slope-intercept form when looking at a graph. So I want you to please make sure you take your time and look at all 6 videos. And then I know sometimes like you might not have graph paper right now, or it might be difficult for you to take notes when looking at a graph. Just please let me know if you have any questions. All right, so this is number 1 of 6, and I want to talk to you about a perfect point. So take a look at the graph. This blue line, that is the graph. It is a beautiful straight line. It is linear. And a perfect point means right here where our graph, this blue line, crosses this grid in a horizontal and a vertical point right there, if that makes sense. I hope I explained that okay. So like this is a perfect point. It kind of is like a little cross right there. This is not a perfect point. It should be down here, or it would be down there, but it's not. And then this is not a perfect point. That is not a perfect point. That one is. So I always tell my students when you first are given a graph to locate those perfect points and kind of highlight them. So like this one we said was perfect. No. This one is perfect. Because I don't want you to make a point, which there are a whole bunch of points, infinitely many points there. But I don't want you to put a point when it's not a perfect point, because then it won't correctly give you the slope. So like this here, that's not a perfect point. That one's not a perfect point. No. Yes. Okay. And it's yes, it's because this blue line, this graph crosses exactly where these 2 lines of the grid cross. Okay. And so I'm going to highlight that as well. All right, so we would like to write the equation of this line. And the equation of this line in slope-intercept form would be y equals mx plus b, where m is the slope, right? M is the slope. And b is the y-intercept. Okay, b is where the blue line, that graph, crosses the y-axis at. All right, so I always like to find slope first, and you can pick any 2 points that you want. You can pick these 2 points to find slope. You can pick this point and this far point over here. You can pick these 2 points. It doesn't matter. The closer the points are together, though, the less reducing you potentially have. So I'm going to pick 2 points that are close together, and so remember slope is rise over run. So I'm going to jump up how many as I'm rising? 1, 2, 3, and I'm stopping at 3 because it is straight in line with that perfect point. So I know that for my slope, I know that my rise is 3. So I'm going to write the slope, which is m, equals the change in y over the change in x. So how much is it changing in each direction? And we're going up 3. So the slope is going to be 3 over. And then how many are we going over? And we're going in the positive direction. 1, 2, 3, 4. Positive 4. So if you're going up and down, that's the y. But if you're going up, it's positive. If you're going down, it's negative. If you're going to the right towards these positive numbers, right? If you're moving to the right, that's positive. And if you're moving to the left, that's negative. And that's important for you to write the slope correctly if it has a negative or if it doesn't have a negative. So now that we have our slope, I just always recommend to come down here and say, well, y equals 3 over 4x. Don't forget the y, don't forget the x. They're important in this equation. And then plus b, where does your line cross the y-axis at? That's a y-intercept. And it crosses it at a positive 1, right? This is 0, 0, and it's going up 1. That's where this graph crosses the y. And so therefore we would put a 1 here, and then that is the equation of that line. Y equals 3 over 4x plus 1. Good? Okay. Let's do another example, and I'm going to start off with writing y equals mx plus b, which is slope-intercept form. All right, let's locate our perfect points. Looks like 0, 0 is a perfect point. Cool. Man, I don't see any other ones on the graph, but I do, they're going to go through this perfect point, right? Because that doesn't work, that doesn't work, that doesn't work, that doesn't work. This one works. No, 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 no. And so it looks like it's at the ends, okay? So don't ever forget that it can be right here on the edge. So now let's go ahead and find our slope. Our slope is m in our equation, and our slope is the change in y over the change in x, rise over run. So change in y is, and I'm going to pick these 2 points. I'm going to go up 1, 2, 3, 4, 5. And I'm going back 2. So I went up positive 5, but I'm going back 2, which would be a negative 2. Awesome. Okay, so I can't simplify 5 over negative 2, so I'm just going to come down here and write it in my equation. Y equals 5 over 2. I'm going to put the negative out front. If you just have one negative, right, if you just have one negative, you can choose to kind of put it out front, which I always do. And so that's why I just kind of have it out here. And then we can't forget about our x. I know some of us wish we can, but we can't. It's always there, right? And then plus b, where does our graph cross the y-axis at? It crosses it at 0. So you have a choice. You can write plus 0 for sure, and it's correct, right? Or you can just not write it at all, and then we automatically know that it's 0 because it's nothing there. So another acceptable answer would be y equals negative 5 over 2x, and that is it. All right, 2 down. Here we go. Let's do number 3. Number 3, I want you to locate perfect points. So right away I see that one's a perfect point, that one's a perfect point, that one's a perfect point. And the more that you do this, the more that you're going to be able to locate those perfect points. I'm also going to write down the y equals mx plus b, my slope-intercept form, and I'm going to find slope, rise over run, and I'm going back 2, so I know that this is going to be a negative slope, right? Our slope is rise over run, which in high school we start to say it's the change in y over the change in x. And we're rising up 1, and we're going back 2. Up 1, back 2. I don't know why I just wanted to write that twice. Oh well. Okay, so then we have y equals our slope x, and then where does our graph, our line, right, cross the y-axis at? And it looks like it crosses it at a positive 3. So we're going to write plus 3, and that is the equation of the line that's in the graph. That's graphed. Okay, so this next example I'd like you to try on your own. So here it is. Take a pause on this video, take a look and try to find the perfect points, and I will see you back in a minute. All right, guys, I'm interested to see how you did. Y equals mx plus b. Y equals our slope. Here's a perfect point, here's a perfect point, and then there's another perfect point. So looks like our slope is 1 over rise over 1, 2, 3, 4, so a positive 1 over 4x. And the b is a negative 3. Now you could have wrote plus a negative 3, that's okay too, but usually we start to move away from that because we know plus and negative is really addition times subtraction, which the subtraction wins. So our final answer, y equals 1/4 x minus 3. Okay, the next two are super cool. I love them actually. What do you notice? It's going straight up and down, right? So like if you stood and did not bend your knees or anything, like if we were in class, we would literally try this out. If you stood and didn't even bend down, could you jump straight up? No, it's impossible. We cannot levitate straight up. So the slope of this line is undefined, right? Rise over run. If you take a look, if we're doing rise over run, I mean, we're not running, we're just straight rising up, which is really impossible to do. So, I mean, naturally. So this slope here is undefined. And so then it becomes a little bit different. The line, our graph, it doesn't cross the y-axis. So it's not going to be a y equals situation because it doesn't even cross the y. So it is going to be an x equals situation because it does cross the x. And where does this cross the x at? It crosses the x-axis at a positive 1. And that's our equation, guys. There's nothing else that we can do. There's no slope because it's undefined. And I just want to show you this. So like this is your y-axis, right? And this right here never crosses it. And so if our graph never crosses the y, then it should not be a y equals. It has to be an x equals, and it has to be exactly where x equals. X only, it only crosses the x at 1. Okay, so one more. I bet you can kind of figure out what it is. Instead of it crossing through the x, what if it only crosses through the y? Right. So let's take a look and see here. It is going to cross the y-axis, or it does. So we are going to start off with y equals. Now, the slope of this line, rise over run, this slope is 0, right? You can sit down and like move with your feet and just kind of just do this. There's no nice slope. It's a really boring sledding hill, basically. And so this slope is 0. And then where does this line cross the y-axis at? Well, it crosses it at a -2. So don't forget the x though, right? That's always something I always see students doing. They forget the x, they get into the motions, and this is that y-intercept form, y equals mx plus b. So we can't forget about the x, which I almost technically just did. But what is 0 times x? 0, right? 0. So therefore, we can simplify our equation to just say y equals -2. Which makes sense, right? Because this line only crosses the y-axis at -2, and the slope is 0. All right, I hope you guys enjoyed this video. Please get a hold of me, email me if you have any questions on these graphs on your assignment, and I'll see you guys later. Bye.